Very good. Well, first let me just apologize for being a bit late. Our session just ended a few minutes late. I'm Roberto Lenton. I'm the Executive Director of the Water for Food Institute here at the University of Nebraska, and I'm very happy to welcome you to today's press briefing. As I think you all know, the subject of this conference is too hot, too wet, too dry, and building resilient agroecosystems. We have about half an hour now to give listeners and viewers some of the top-line thinking around climate change and resilient agroecosystems, which has been a focus of our sessions yesterday and continuing today. You all have biographies of the conference speakers in the conference website, so I don't think I will go at length into each person's bio. But what I wanted to do today is to begin with some comments about climate itself, and so I wanted to ask Heidi Cullen to start. She's the chief climatologist for Climate Central, a nonprofit science and journalism organization, and she's also the author of the book The Weather of the Future. So Heidi, would you like to kick off?
Sure, and I guess, should I come up and...
I think so, yeah.
Microphone is generally useful, right? So, I think maybe just in terms of updates, two big things coming up in the near term. One is the National Climate Assessment, which is a wonderful document that's going to provide an excellent overview of the impacts of climate change in the United States across all sectors, all regions of the country. And I'd say, some of the top-level findings from that report really show us that we can see objectively the climate change is happening right here and right now in the United States. So we're seeing an overall warming trend, say for the lower 48, it's about 1.5 degrees. Some parts of the country have experienced more warming than other parts of the country. And then with respect to precipitation, we're also seeing this expected shift towards, if you will, heavier rainfall events. So it's kind of the rich get richer, the poor get poorer. So when it rains heavier. There's longer dry spells in between. We've seen a 74% increase, for example, in these heavy rainfall events in the Northeast. And then the models, I think, continue to show this consistent signature of increased drying in the Southwest. So the National Climate Assessment, really, really great document. The final release will be in March of 2014 for that. Another obviously big announcement coming out will be through the IPCC, the Intergovernmental Panel on Climate Change. Working Group 1, which is the science finding, will come out at the end of September. I believe September 27th is when the IPCC report, next iteration, will come out. And I think, the interesting findings from that are that our models are getting better. We're getting higher resolution on shorter timescales, if you will. So, again, the picture for the end of the century is that if we continue business as usual, we're heading towards a planet that's somewhere between 7 and 11 degrees warmer. And that there will be variability on timescales within that. So two really, really big reports coming out. And I think, the overall takeaway is that as the planet warms, we expect to see more extreme events. So more heat waves that last longer and cover higher, larger areas, if you will. And that the risk for drought continues across the Southwest. And that the kinds of extreme rainfall events that we've seen are expected to continue as well. So the resilience theme that we've seen here today, I just think it's critical. This theme of taking the data, incorporating it into our long-range planning, and really putting the mechanisms in place to become more resilient and more adaptive to the changes that are in the pipeline.
Very good. Well, Heidi, thank you so much. And now we want to turn to a discussion of how climate change can impact public policy. And so I'd like to ask Rosina Birban to say a few words. Rosina is from the University of Michigan. She's a member of the President's Council of Advisors on Science and Technology. She's an Adaptation Fellow at the World Bank, and she leads the Adaptation Chapter for the congressionally mandated U.S. National Climate Assessment. She's also a review editor for the IPCC. So, Rosina.
Well, thank you very much, Roberto. So as we heard from Heidi, there are a lot of physical changes already occurring, the increase in temperature, the increase in precipitation, the increase in evaporation, which is leading to more extreme events, floods, droughts, heat waves. And it's very clear that whether we're talking about the United States or the rest of the world, it is the poorest in those countries that will be impacted the most. And we really care now about this so what question. So what do those changes mean to people in their particular place? There's a real regional flavor to how climate change will play out. It will interact with other environmental stresses. So if you're a coastal community, the increase in sea level rise is going to flood cities and affect saltwater intrusion of water systems. If you're in an area that's a big crop growing region like we're in now in Nebraska, the change in rainfall patterns and drought patterns will absolutely affect crop productivity. And so there's now a very much increasing attention on this so what and so what can we do about these changes, because they are very much affecting people in their places differently. And so that leads, as I think Roberto was implying, to thinking much more about coping or resilience or adaptation to climate change. And I think for far too long, people have avoided thinking about adaptation to climate change because it somehow meant we were giving up. But it is very clear that the rate of change we're seeing and the magnitude of change we're seeing in climate change is causing impacts now that we're not particularly well suited to cope with. And so our quick attempts to respond reactively, as it were, to Hurricane Sandy, to the incredible drought of last year, make it clear we're not prepared to cope with the droughts and floods today, let alone the impacts that will be coming tomorrow and the increasing frequency of these. So this argues very strongly for having the public prepared for and having the government assist the public in being prepared for climate change. And so you're seeing an increasing attention at the national level, at the local level, at the regional level, at the state level, in preparedness for climate change. And I think this word is really very helpful. I'm on, as you heard, the President's Council for Advisors in Science and Technology. We delivered a 9-page letter report to the President at his request a few weeks ago that said we really need to begin a national conversation on preparedness to help communities understand what climate change will mean to them and to help them prepare for them, to make sure that the federal agencies are providing usable information, not just a profusion of data, but data that can actually be used to help communities deal with the increasing floods, droughts, heat waves, wildfires. And so I think at the national level, there's going to be a big push to combine and make available public data that will help communities prepare. In the study of adaptation that we did for the National Climate Assessment, I was very surprised to find that there are thousands of adaptation efforts beginning principally at the city level, and they are doing this without a lot of help or a lot of best practices being aggregated to offer to them. So they're really sort of 1,000 flowers blooming as communities and cities deal with these issues every single day. Keene, New Hampshire, one that we see a lot in the news, realizing they needed deeper culverts to deal with extreme flood events. But these cities need to have sort of the influx of information that is available from states and from the federal government, and to be able to share best practices with each other. So I think a national conversation on adaptation needs at every scale is in the works, and also, of course, stemming the pace and magnitude of climate change is very important, because if we do not mitigate and reduce the steep trajectories that were mentioned by Heidi, we will outstrip our ability to adapt. So adaptation, mitigation, co-equal, finally on the same page, and I think interaction between what it is the local governments need and the federal government can provide to meet in the middle with usable information, very important, nascent, but starting step forward. Thank you.
Well, thank you so much, Rosina. The next person you'll hear from is Mark Svoboda. I think many people in this room know Mark. He's the monitoring program leader of the National Drought Mitigation Center within the School of Natural Resources here at the University of Nebraska-Lincoln. So, Mark, do you have any news to share with us on the evolving drought?
Good morning. Thank you, Roberto. As we've heard already here this morning from Rosina and Heidi, a lot about extreme events. So it's a good segue to talk about what was indeed an extreme event last year in the drought of 2012, where we had the warmest year on record for the U.S., and in fact, where we're meeting here this week for this conference for Water for Food. Nebraska was indeed not only its driest year on record, but also its hottest year on record. And so we had several states that had their hottest year on record. And much like real estate's about location, droughts are a lot about timing. And so we heard Heidi allude to the number of dry days, and that is a concern on the timing of these rainfalls. So sometimes it's a little bit misleading to look at the total amount of precip and not understand how it's distributed. So is the drought of 2012 sort of a harbinger of a warmer climate? We saw last year many of these states were some 4 to 5, 6 degrees above normal Fahrenheit compared to the normal. And as we saw Rosina talk about yesterday, if you look a few decades into the future and look at projected temperatures, if that's sort of our new normal operating parameters for our summers, for our years, where we're already seeing warming, particularly in the winter, then I think, these extreme events, drought in particular, is going to be something that we have to be very diligent with moving forward. So as we move into 2013, after an apex of about 2/3 of the country in drought as of late September of last year, we've eroded away at the drought, particularly in the eastern corn and bean belt, say from Ohio, Illinois, Indiana, and eastern Iowa, Missouri as well. We've had some very beneficial storm tracks here of late that have just cut right across the epicenter of the drought through the Midwest up toward the Great Lakes. That was very, very welcomed, as it had been a very dry, relatively dry winter, much like a replay of last year, in fact. So we were very concerned. We had a lack of snowpack in the Rockies, which is feeding both not just the west side of the divide, but the east side of the divide, as we saw record low inflow into the Missouri Basin, the largest basin, which then you saw impacted the Mississippi and barge traffic. Those impacts were rearing their head last summer as well. So we've had some big storms in the Rockies as well. It's only brought it up to just around normal to a little below normal. So we're not all the way there. Coming off a very dry year last year, it's enough to sort of keep the system status quo, but definitely not enough to improve the situation enough that we're not concerned that we don't need any more rain. We do need more rain. We see in the high plains part of the country, still very, very dry, including western Nebraska, South Dakota, Kansas, eastern New Mexico. These areas have been desiccated, the pasture and rangelands. So it's not just row crops, it's the livestock industry as well. So we'll see what moves forward. We're kind of coming into a time of year, though, where the forecast have trouble looking out into the summer. It's usually a difficult time to forecast anyway. Last winter didn't bear out very well with the forecast because we were pretty neutral in the ocean that really drives our weather. And so we're sort of, just kind of hoping more than predicting that, yes, we're going to come out of this drought. It's such a large area. We're still just under 50% of the U.S. in drought, as I mentioned earlier. A lot of that is very, very extreme drought. So I don't anticipate that that'll all be eradicated, but this April's been, like I said, just exactly what the doctor ordered, and we'll see what May brings us as far as future prospects going into the summer of 2013. Thank you.
Great, Mark. Thank you so much. And our last speaker here is Cristo Fabricius. Cristo is the science leader of the Resilience Alliance, and he's also the leader of the Sustainability Research Unit of the Nelson Mandela Metropolitan University in South Africa. So, Cristo.
So my reflection is just on the phenomenal impact of processes happening at a global level, particularly in the United States and in China, on food security in my part of the world, which is sub-Saharan Africa. So in sub-Saharan Africa, communities are really sitting ducks for these processes. They have very little control over them, but they feel the impact. And we see the drought in America, for example, influencing maize and food prices in South Africa, in Mozambique, in Angola. We see people getting angry, riots on the streets, because of food price issues which are beyond their control, influenced by a combination of climate change, influenced also by crop subsidies in the Northern Hemisphere. And it's really a very difficult situation for the food producers and consumers in sub-Saharan Africa. One of the issues is as food consumers move up the food chain, so what happens is that their disposable income increases, and they do a shift, and they shift to meat and fuel consumption. And when that happens, of course, it creates other shortages and this knock-on or domino effect. And what then happens is that the poorest of the poor, really surviving on $2 a day, are really feeling these increases because food makes up 70 to 75% share of household income in some of those communities. So a small increase in the food price pushes people over the brink. So what are the solutions? The solutions, from a resilience perspective, is first of all to look at all these problems through a multi-scale lens. In other words, look beyond the local scale. Look at slow factors that are changing at a global level, that are creating tipping points in local food security. Second issue is looking at it through a social ecological systems lens, and that's that the social and the economic and the ecological are coupled across all these scales. Third issue is to work on connectivity. In other words, we might need a global pact for food security where all the role players actually connect, share information, share awareness about the same problem, share a similar vision of food security for the planet that looks beyond the national boundaries. Connectivity between scientists and villagers, connectivity between extension officers and villagers. And the other issue is governance, and that is good decision-making structures that can get around issues such as corruption, failed states, irresponsible land transfers, those kinds of things that start collapsing when good governance goes down the tubes. Thank you.
Very good, Cristo, thank you, and thanks to the previous speakers. We've got about 10 minutes now for question and answers. So direct your questions at whoever you would like to or all four. But the only thing I would ask is if you can just state your name and the organization that you represent, and also if you do want to direct the question to whom it should be directed. So the floor is yours.
So climate change includes the warming temperatures of the planet, but climate change, I think, is a better all-encompassing term because with that increase in temperature, you also get this speeding up of the water cycle, which leads to this increased evaporation, more total rainfall, but more drought in the interior of continents, and you get sea level rise. So I think global change is a better term than just talking about one thing, the temperature, which is global warming.
Why is it different now?
So we are seeing actually a speeding up of the melting of the great ice sheets. This is one of the things where uncertainty cuts the wrong way, as in our physics models did not actually predict that the melting of Greenland would occur as fast as it's occurring. In fact, briefly last summer, the entire surface of Greenland, land-based ice, which contributes to sea level rise when it melts, was melting simultaneously. So we've actually seen sea level rise accelerate from what used to be about a 1.7 millimeter increase a year to double that in the last few decades, and it's now widely believed that that is due to Greenland melting at this very, very fast rate. So sea levels are rising. I hope we won't be under that much water as fast as you suggest it could happen. But recently, the global estimates of sea level rise in the Intergovernmental Panel on Climate Change and in other peer-reviewed literature that's come out has suggested a 1 meter or 3 foot sea level rise by the end of this century as the global average is quite probable. And so in previous years, it wasn't thought to be that much. So these numbers have bounced around a little, but the sea level is rising, and the rate at which it's rising has doubled in the last several decades. And that is consistent with ice melt and global warming and climate change.
I think what our listeners are concerned about is that it seems like they have the attitude that there are no cycles, natural cycles, that the administration wants to blame it on human interaction.
So there are very long-term cycles. There are glacial and interglacial cycles, and those are on the periods of tens to hundreds of thousands of years. And we have been in an interglacial for about 12,000 years. And so you would expect, if there were no greenhouse gases, that the Earth would slowly slide back into an ice age. However, the greenhouse gases that we've added to the atmosphere trap several degrees of heat. And so, as Heidi was saying, we've already increased 1.5 degrees Fahrenheit, and the expectation at the rate at which we're increasing emissions is that we'll take temperatures to something like 9, 10, 11 degrees Fahrenheit by the end of the century, potentially above pre-industrial levels. That's about the same amount above at same temperature increase that an ice age drop would be. And so what we're doing is the human heat trapping is overwhelming any of these long, slow natural cycles at the current moment. So we're actually skyrocketing with heat trapping gases. So if you look at the glacial, interglacial period, the concentrations of carbon dioxide in the atmosphere varied from about 170 to 270 parts per million. We're almost at 400 now. We know that that hasn't been true for at least 1 million years. So the human pressure on the natural cycles is so apparent. And you cannot reproduce the temperature of the planet for the last, especially 50 years, without including the heat trapping of greenhouse gases. So there are other shorter-term cycles, the El Nino cycles, solar cycles, etc. But again, those are now being damped significantly by the huge amounts of greenhouse gas added, and the planet is responding to those in a very serious way. So if you look at the last concluding sentence of the Intergovernmental Panel on Climate Change from 2007 was that these impacts are unequivocal and that they're more than 90% confident that this is due to human impacts, that it's due to human-induced greenhouse gas climate change. So the science has gotten actually very much better in the last 20 years. Thanks.
Let me also mention that those on the telephone, feel free to ask questions.
I came in late, so if this was answered, we'll need to answer it now. But I believe you mentioned that interiors of continents are more prone to drought. Can you elaborate on that?
Sure. Maybe the simplest way to think about it is the way high-pressure systems are placed throughout the globe just will be intensified so that the high-pressure systems kind of get bigger and stronger. And so those places that are already prone to drought are expected to kind of get supercharged, and so those droughts could intensify. And as Mark was saying, that just the rains will still come. It's this duration between which the rains fall. So we're going to see kind of an exacerbation of the way some of these pressure systems are influencing the lack of rain in different places. Mark, do you want to add to that?
Well, that's kind of why I raised the question of if 2012 was sort of a look into the future with warmer temperatures. There's, you know, we're starting to get a better understanding of the interaction between these various oscillations of the oceans which drive our climate, and then how we couple these models with feedback mechanisms such as the interaction between what we had last year, which was a very soil, we deprived all the large land mass of soil moisture, and this was a very hot, dry air over a moisture-starved soil. And this is a term we use when we talk about droughts feeding on themselves that you see in the continental regions of the large continents. So without a major water body there, with the rain shadow of the Rockies, this is an area that's primed to heat up and dry out, and rather quickly, as we saw last year. And so I think moving forward, of course, this drought's not over, so historically we can't really put it in its proper perspective quite yet, although we had a lot of questions about the heat of the 30s and how that affected droughts at that time. Of course, we've had a lot of changes in land use practices since that time, but we also saw a lot of dust storms in some areas that have been really, really desiccated that look like a moonscape if you look at western Oklahoma and parts of eastern New Mexico. These areas are, again, under these high-pressure areas, and these domes sort of feed on themselves. And with a warmer climate, yes, you hold more moisture in a warmer atmosphere, but you have this influence of the high pressure that leads to the duration between rain events. And then when these soils become encrusted, as we saw Cristo allude to in his talk, when rain hits that, it's almost like concrete and can be very ineffective rainfall at that when it's intense. And so these intense rainfalls aren't as beneficial as we would like to see either. So these are some of the things we have to, I think, take into account when we put droughts now as compared to maybe in the future.
Thanks, Mark. We have maybe a couple of minutes.
I think this might have been discussed yesterday, but you mentioned how warm winters are a signal of climate change. And were you saying yesterday that summers, that now we're seeing summers as a signal of climate change also? Is that kind of...
So I think what Mark was referring to is we talked about how the extreme summer in 2003 in Europe, the incredible heat wave killed 35,000 people in a relatively rich part of the world. And what the models project is that temperature, which would be extreme in one not affected by greenhouse gases, will become the norm a few decades from now and will be actually considered cool temperatures by 2060. So heat waves and protecting people as climate change proceeds is going to become a very big issue. Of course, there are ways to deal with this, but I would argue preparing for it as opposed to reacting to it is very important. We've seen some countries of the world hit over 120 degrees in recent years, and some of those very poor countries, of course, do not have access to ways to air condition and all that. Even the rich countries in Europe, which still lost 35,000 people in 2003, did. And we've seen heat waves increasing in many parts of the United States as well. So yes, hotter summers will become the norm. Some of the projections from the National Climate Assessment that Heidi referred to suggest that parts of the Great Plains region will have temperatures of over 100 degrees Fahrenheit for 30 days each year by the end of the century.
Can I make a point to elaborate on that a little bit?
Yes, Mark, and then we could probably go.
So I think to segue off of what Rosina just said there, this recent drought that really started back in the fall of 2010 was due to a lack of winter. This is a time of recharge. This is a time when demand is low, the environment sort of catching its breath, if you will. That's when you recharge your soil moisture. We didn't do that heading into 2011. We didn't do that really heading into 2012. And so it was really the lack of winter. You know, the system needs that sort of, and talking about accelerating the cycle, that's what we're doing. There were warm temperatures. We had heat waves in Texas in February. We had heat waves in March, June, and July, and a lot of that's because the soil moisture was already dried out because it did not recharge. There wasn't a lot of snow, and going into spring and summer, we were already behind the 8 ball. So then if you throw a hot summer on top of that, that's really what exacerbated that drought.
Well, unfortunately, we'll have to bring this to a close because the session is going to be starting up upstairs. Let me thank all the presenters for comments and all of you for being here. If you have any follow-up questions, you can contact John Deutscher there at the back, and there's also information on the website, and yesterday's press briefings and the web stream material is also on the website. So thanks again. Thanks for coming.